Okay, we're going to talk about operations on indices, so like exponents, and on surds, so irreducible square root values, or any sort of root values. Um, so the first thing we're going to look at are the laws for indices. So how do we deal with exponents, simplifying and rewriting, and so forth? The first law is that if you have like bases multiplied by each other, you are to add the exponents. So for example, for number 1, if you had like 2 squared times 2 cubed, you would add these exponents and get 2 to the 5th power. Well, I mean, if you break that down and try to make it make sense, this is 2 times 2. This is 2 times 2 times 2. There are 5 of these. You get 2 to the 5th. Okay. Second example says, well, if we are dividing those, so kind of the inverse of multiplying, then you are going to subtract the exponent. So you're always going to subtract one from the other. So, for example, here, if you had 2 cubed over 2 squared, okay, well, 2 cubed over 2 squared, you are going to take the 2 and subtract it away from the 3. So you get 2 to the 3 minus 2, which is 2 to the 1st. That's how you would find that answer. 3 tells us that if you have groups of a base to an exponent, so if you're taking an exponent to another exponent, you multiply them. So a to the m then to the n is a to the mn. So that would be like if I had 2 cubed and then squared that. In this case, you would multiply, so you would have 2 to the 6th. A lot of people want to multiply the exponents here, but you need to think about what an exponent is. An exponent is counting the number of times you're multiplying. So if you're multiplying, you just add. You're just counting the number of times that you're multiplying. Here, taking something to an exponent is like stacking. This is 2 groups of 2 times 2 times 2's. They're 2 separate groups. And so that's why we multiply there. Our fourth says, this is one that a lot of people oftentimes forget too. Like if you have, let's say something like, say we have 2x, okay, squared, okay? You not only have to square the 2, but you also have to square the x, right? If you're multiplying, if an exponent is applying to more than one thing, more than one factor of an expression, you have to make sure you take care of that. And so this is the same thing as 4x squared. 5 tells us that any number to the 0 is going to give us 1. So like 5 to the 0 or 2 to the 0, it makes 1. So does 3 to the 0 and 4 to the 0 and etc. And finally, writing our answers out. So like if you had like a to the m over n, this number, the number on top, I call it the power, and the number on the bottom, I call it the root. And so you can write these in many, many, many different ways. But the main 2 ways that you're going to see are going to be like this. You're going to have your root, which is n, and then your base to that exponent, or you could see it written like this, n to the m. The m could be on the outside or the inside. It's whatever you prefer. But while whatever is in the denominator of that fraction is going to be the root, and whatever's in the numerator is going to be the power. So it's kind of like being in between regular rationals. So the next concept we're talking about is what happens when you rationalize. So if you have like a single term in your denominator, so like in this case you have 1 over the square root of 2. We've worked on this before where as long as we multiply by 1 or something over itself, then we can do that without changing an expression. Well, because it's the square root of 2, we want to multiply easily by the square root of 2 on top and bottom in order to get rid of it. So like if you had like 3 over the square root of 6, okay, you would want to multiply to get rid of the square root. You would obviously want to multiply the bottom by the square root of 6 to get rid of it, make it a 6, but you need to also multiply the top by that too, because this whole thing equals 1. And multiplying by 1 doesn't change anything. So you're going to end up with 3 times the square root of 6, because these just combine. The square root of 6 times square root of 6 is 6. And then you can actually even simplify this further. There's 3 over 6 is the same thing as 1/2. So this is like 1/2 of the square root of 6, which you don't even need the 1. You can just say it's the square root of 6 over 2. And then we can make this a little more complicated. What if we have 2 terms in our denominator? Well, the concept here is that if you do the difference of squares is this concept of factoring and kind of multiplying, where if we were to FOIL, our first would make a squared, our outsides here would make ab, our inside makes negative ab, and our last makes negative b squared. Well, notice that these cancel each other out. When we see this particular form, a minus b times a plus b, we get rid of our middle terms. And this is really key because if you look at a problem that has square roots like this one, the middle terms would have square roots in them as well, which we can't have because you can't have square roots in the denominator. So if we decide, hey, let's use this to our advantage and get rid of these square roots in our denominator, this is the only way to do that, for sure, is to go ahead and use the difference of squares in order to get this done. And so I will, you can look at the example on the left and kind of follow along with the logic of it, but I'm going to make up my own example. So we'll say that we have 4 over 2 minus the square root of 3. Well, 2 minus the square root of 3, as I said, so that's like a minus b. We want to multiply by a plus b in order to get our a squared minus b squared, to get rid of those middle terms. So we are going to multiply this by 2 plus the square root of 3 over 2 plus the square root of 3. Now, in this particular case, we square the first and subtract away the squares of the last. The middle terms disappear altogether. So this is going to give us 4 times 2 plus the square root of 3 over 2 minus the square root of 3 times 2 plus the square root of 3. The top would simplify to make 4 times 2 gives us 8. 4 times square root of 3 gives us positive 4 times the square root of 3. And the bottom is going to give us 2 times 2, which is 4, minus the square root of 3 times the square root of 3, which makes minus 3. Now, again, the reason why I can do this is because the middle, or the inside terms, 2 times the negative square root of 3, and the outside multiplied together, cancel each other. So I just end up with this. And so this answer down here actually ends up simplifying to make 1, which means that I can actually just get rid of it altogether. And so you're left with this. So the main key here is just identifying the right kind of conjugate to multiply by, and then doing your operations correctly.